blast off. So we are going to be looking at the relationship today of the peasant's plan versus the relationship of the balance, in the hopes that we can come to a better understanding of what makes an exponential equation. That's the big purpose. But also, we want to talk about that peasant's plan and see if it is a good plan, because we don't really know how much money is on that chessboard. Now, for those of you who are watching this video not in 2020, I'm sorry to say you missed the story, but it was a good one. Wouldn't you guys agree? Your talking doesn't go on the video anyway, so sorry. Okay, so here we go. And this is where I need some help. So in investigation 1.1, we had a table, and we had the number of ballots. No, we had the number of cuts and the number of ballots. Am I remembering correctly? All right, so at 0 cuts, how many ballots did we have? 1. At 1 cut, how many ballots did I have? 2. At 2 cuts, how many ballots did I have? 3. And okay, so what's the pattern that we're seeing here again? It's doubling, okay? And doubling is multiplying by 2. I'm going to go to 5 cuts, so we get 32, not 33, because 32 is 16 times 2, which is 32, okay. And then we said that there was an equation. What was the equation that we came up with when we have X number of cuts? What was that equation that we had from investigation 1.2? Right, exactly. So I'm using Y's and X's. We use B's and R's for rips. So and we had Y is equal to, I'm using Y and X to have a little more standard notation because that's what we're looking for by the end of today. Y is equal to 2 times the X power. So 2 to the second is 4, 2 to the first is 2, 2 to the third is 8, 2 to the fourth is 16, 2 to the fifth is 32. That makes sense. All right, so then we had this beautiful story about the king reuniting with his son who is drowning and offering a reward to a peasant who has a chessboard, and she has squares on the chessboard. I love chess. And we have pennies. All right. So on the first square, I'm just trying to line this up here. On the first square, how many pennies did we place on the chessboard? 1. How many pennies did we place on the second square of the chessboard? How many pennies were on the third square of the chessboard? 4th? 5th? All right. So right now, what I would like you to do is I would like you to take about 90 seconds. I would like you to take 90 seconds, and for those 90 seconds, I would very much appreciate it if you could try to find some connections between the two tables. What similarities do they have? What differences do they have? Let's find some connections that we can use to help find that pesky equation. So you got 90 seconds. Why don't you get going? 90 seconds. Okay, so welcome back. I know that you paused the video so you could find those connections, but we are back after about 2 minutes. Excellent. So, yes, Miss Lloyd, what did you notice about the two tables? Okay, so you noticed that the number of cuts and the number of squares are going up by 1 every time. Now, it may be obnoxious to you guys that I'm repeating what you say, but since what you say is not part of the video that I'm making, I am going to repeat what you say so that people who are watching in the future can hear or what your thinking was, okay? So that's why I'm repeating it. All right, Lily, you're absolutely right that the number of cuts and the number of squares both are increasing by 1. Perfect. Are there any other observations about these tables?
Max.
Max. No, doubling. Doubling is the right vocabulary there. So you're right. You're absolutely right. So between the ballots, we are multiplying by 2 every time. And that's going to continue. I'm just going to do the 3 dots to show it's continuing. And in the peasant's plan, we are also multiplying by 2 every time. That is absolutely critical to notice when we're talking about these 2 tables. Are there any other observations you've noticed about these 2 tables?
Lauren.
Lauren? Okay, so hold on a second. So on the first table, at 5 cuts, there are 32 ballots. Okay. And go on. So there are 16 pennies on the 5th square, but on the 5th rip or cut, there are 32 ballots. What is the connection between 32 and 16, Miss Lauren? 16 is half of 32. Well, wait a second. Does that pattern persist for the whole table? Is, for instance, okay, so 16 is twice of 8, or 8 is half of 16. 4, I wanted a different color because the green hurts my eyes. 4 is half of 8. Okay.
Hannah has her hand up.
Hannah. Okay, so that is really difficult for me to repeat, but I'm going to try my best. And you're probably going to have to feed me words, Hannah, so that I am repeating what you said correctly. Okay? And I'm sure that the repeating is good for about half of you because online school gets boring at times. So you said that, I'm going to use my favorite red. You said that these values in the first table are twice the values of the second table. And you said that the y-intercept of the first table, when x is equal to 0, you have the number of ballots of 1. And then you got a little bit quiet in your explanation. What was the y-intercept for the second table? Well, so hold on a second. I'm not sure that's exactly right because we have this pattern of multiplying by 2 every time. So if we work, it's 1/2. That's right. So we have half a penny on the 0th square of our chessboard. Is it possible to have a 0 square? No, but we still need to have that y-intercept. So we have half of a penny on that. And you said that this table here is twice this table here, or another way of putting it, this table, the second table, is half the first table, and you also notice that the y-intercept is 1/2. Very, very suspicious. I think there's a connection there. All right, so the next question I have for you before we start talking about the questions you're going to answer today in your investigation if the equation for the first table is y is equal to 2 to the power of x, how are we going to manipulate or change that equation so that it will fit this table right here?
Allie Dolan.
Miss Dolan. May I try to put words in your mouth? Would it be fair to say that this table, the table of squares and pennies, is always one spot behind the table with the ballots? In other words, 1 is occurring with 1 here, but it's occurring with 0 here. 2 is occurring with 2 squares, but it's occurring back 1 square here. So we're actually just subtracting one level of the table to get the same thing that we would have gotten here, just back 1. How's that for putting words in your mouth? That's good, okay. The minus 1 is both part of the equation, and the minus 1 is part of the exponent. Hey, my buddy the wasp is back.
Yep.
I've been dying to have a class pet, true story. But the class pet that I want is going to freak out some of my teacher teammates. Do you guys think I should get a class pet?
Can't have one. Fire department said no. Seriously.
No class pets?
No class pets.
Are you kidding?
No. Michelle's very upset, and she said she's going to pay the fine, and the fine, they said, it's going to be heavy.
Can you imagine what is Miss DeMullen going to do if she can't have her pets?
She's very upset.
Just tell me when the fire marshal comes, I can get my pet out of there.
Okay.
Okay.
Just no insects, Lauren says.
Oh, don't worry, it wouldn't be an insect. I really, really want a boa constrictor. All right. Let that sit for a bit. Okay, so I totally agree with Allie, but guess what? There are 2 other ways we can write this equation. There are 2 other ways that we can write this equation. I want to go back to the discussion that we had earlier about this table being half this table. So what can I do to this equation to reflect the fact that this table, that 8 is half of 16, and 16 is half of 32, and 4 is half of 8? What can I do to the equation?
I got no hands.
No hands?
No hands.
The song is I've got no strings to hold me down, not I've got no hands.
Oh, sorry.
Okay, Claudia, let's go. You're my go-to hand raiser. How are you doing today, Claudia? Okay, so what could I do to y is equal to 2x that would take the values from this table right here and make them half? Divide by 2. Okay. So I could also say y is equal to x, 2x to the x power divided by 2. Okay, that makes total sense. Or, what's another way of saying divided by 2? Times 1/2. So I could also say y is equal to 1/2 times 2 to the power of x. So that means that the super insightful -1 in the exponent has to equal the divided by 2 and the 1/2. That's what that means. All right, are you ready to have your...
Says yes.
Are you ready to have your minds blown? Always. I love it. So here is our mind-blowing moment right now. I'm going to take a picture of the equations so that we don't forget them because, again, I'm old and had a few too many hits to the head, and I will forget them. Okay. So we have our equations. All right, I'm going to go way back to our first investigation, and we said 2 to the third was what? It's 8. In standard notation, it's 8. Okay. 2 to the second is 4. Perfect. So I swear, no tricks. 2 to the first is equal to 2. So what exponent comes now? 2 to the 0. So I'm dividing by 2 every time. So 8 divided by 2 is 4. 4 divided by 2 is 2. 2 divided by 2 is 1. So if I continue this pattern, and math is simply a study of different patterns. So if you find the pattern, you know you're right. So if I have 2, what's the next exponent going to be? 2 to the negative first is going to equal, so following the pattern, what am I going to have? 1/2. So negative exponents exist. You're going to have to wrap your head around that. They are out there and they are real. Negative exponents do not provide negative numbers. Negative exponents will give you a fraction. Negative exponents will give you a fraction. And notice how, when we had a negative 1 in the exponent, we had this half up here, didn't we? That is not a coincidence. That is because 2 to the negative first is equal to 1/2. And that's why when we had this negative exponent here, we had the 1/2 in the equation.
Lauren has her hand up.
Yes, Lauren? I do know that answer. So the question was, why does a negative exponent not equal a negative number? And so here is the deal. I'll start with this. So let's say we have 2 times 2. 2 times 2 is a positive times a positive, right? And a positive times a positive is a positive. Now, let's switch that. If I have a negative times a negative, I'll get a positive. For me to get a negative, I have to have a negative times a positive, or I have to have a positive times a negative. That is the only way that I can multiply things together to get a negative. True? Okay. So, when we have this exponent of -1, we're essentially having the 2, and we're multiplying a positive times a positive. And a positive times a positive is going to be positive. Now, if this 2 was a negative, we'd have a negative times a negative, which is, it's also a positive. So so that's why negative exponents will not produce a negative number, because the rules of multiplication do not provide that. However, I will tell you, so I gave you sort of an untrue statement to show this. If you have a negative exponent that is odd, it is possible to still get a negative number. It'll just be a negative fraction. So I do want to say that I oversimplified things here to prove a point, okay? So you can still get a negative number if you have an odd exponent, and you can get a negative fraction with an negative odd exponent. But that's why it doesn't necessarily create a negative number. Does that make sense? Okay, you're welcome. All right, so, and thanks for the question. That was a good question. All right, so requesting a reward, we already talked about that. The only vocabulary word we haven't talked about is base. So if I have 2 to the 5th, The fifth is called an exponent. The 2 is called a base. That's base, or base. Wrong kind of base. Okay. So if I have this number, what number is the base? 7. Okay. We are going to talk about exponential or scientific notation a little bit today. This E is not an error on your calculator. It means to the power, 10 to the power of whatever this exponent is. So in other words, this number here is 1.0995 times 10 to the 12th power. And we'll talk a little bit more about that in a moment. Are we okay so far? Okay.
No real responses.
I know, it's too much of me talking. We talked about the peasant's plan. So here's what we have for you right now, what you're going to do in your common rooms. You are going to make a table of the number of pennies on the chessboard from 1 to 10. We've already made that table from 1 to 8, so you can just add 2 more, that's fine. Then you're going to make a graph. You're not going to go from 1 to 10, you're going to go from 0 to 5 for the number of squares. We already have that equation, so we're good. I do not want you to do question B. We already talked about that observation, so don't worry about it. So I do want you to do question C, and most importantly, the question I want to know is how many pennies are on the last square of the chessboard? I'm going to add that piece. How many pennies are on the last square of the chessboard? Are there any questions about what I would like you to do?
No.
Okay, so please go to your common room, and I will